All right. So as you can guess from the name of this region, this is a region that's located on the rim of Faustini crater. This is an ancient terrain. It's located between some other well-known craters, Shoemaker and Amundsen, and also Shackleton, and you can just see right off the edge of the image here. So most recent stratigraphy and age estimates place Faustini about 4.1 billion years in age between the ages of Shoemaker and Amundsen craters. However, this still needs to be verified by returning samples and working out the stratigraphy. Of course, there's lots of other craters and ejecta sources in the area, and these events are going to span a large portion of lunar history from pre-Nectarian to virtually the present. This area's composition appears to be largely feldspathic from the Kaguya spectral profiler dataset. And we're also expecting some basic materials in this area based on presentations by others this today or yesterday and recently. Um, and so we might expect South Pole Aitken Basin, Schrodinger, other basins. There's also some light plains in the South Polar area that are thought to come from Oriental. So there's likely to be um, lots of different base material mixed in. So the most prominent crater in this region, besides Faustini itself, is this one that's shown here. It's an unnamed 2.7 kilometer diameter crater. In mini-RF CPR images, this appears to have a rough ejecta blanket, although in the visual data, it appears a little bit degraded. The scale of this crater suggests that it excavates up to depths of a couple hundred meters. Um, and so if we were to sample some of this material around this crater, we'd get some insight into the local stratigraphy. Of course, there's lots of other smaller craters which are excavating to different depths, particularly shallower depths, more on the order of tens of meters. And some of these small craters are actually pretty rocky and are excavating rocky materials, like the one in the center image here. If you can see my mouse cursor moving around, this is a 50-meter diameter crater with lots of rocks. We also see in this region other types of blocks and boulders that around the region. A couple other examples. So that there are examples of large boulder clusters, like the one on the left image. That cluster is about 100 meters across. And on the right image, there's one of these little smaller clumps of boulders and fractured materials. And those are probably ejected boulders. The larger ones here are about 10 meters in diameter. So, looking for things to sample, we found that it was useful to start just mapping out where we were seeing these rocks and blocks and boulders. And so far, this image on the right here shows all the ones that we found so far in this region using NAC images. You can see that lots of rocks are associated with the younger 2.7 kilometer crater and its ejecta, as well as more recent craters superposed on that ejecta blanket. And then also we see a lot of exposures of rocks and blocks inside Faustini, and those are also associated with small impact craters. But elsewhere in the region, those smaller craters are not really, don't seem to be excavating as many rocks, which is interesting. So looking into whether we can actually access these materials to return some samples. So this is a slope map of the area derived from the topography. The blues are the gentler slopes, less than 10 degrees, yellow, moderate slopes, 10 to 15 degrees, and gray are the steeper areas greater than 15 degrees in slope. And the blue squiggly lines, the thin ones, are the 100-meter contours derived from topography. And the circles indicate different prominent craters in the area. And of course, our blocks are still shown with the little yellow dots. And so from this map, you can see that outside of Faustini crater, the slopes are mostly mild to moderate, less than 15 degrees. So lots of things here are potentially accessible. Inside Faustini is much steeper along that crater wall. And also inside these more prominent craters in the area, the slopes are also relatively steep. And there's one area here towards this lower right corner of the map labeled ridge. And this is the area with that's at higher elevation in this region. This is part of Faustini's rim, and it makes about a 2 kilometer long ridge on this corner of the map. And that rises significantly above the other areas within this region. So as you can get a sense from looking at that, there's different areas within this map with different accessibility. So inside Faustini is looking very difficult to navigate because of its slopes, so that's pretty much inaccessible. The ridge area is accessible and it has this nice high elevation, which is probably better for illumination and visibility, but we aren't seeing as many rocks and blocks to sample there. It's also a pretty long hike from there over to that fresh crater where we are seeing more blocks and rocks and things to sample. Um, but that area you can see in this map here, that around the crater and that its ejecta, the right image, it's mostly in the blues and yellows, and lots of those boulders and blocks are potentially accessible. Thinking about volatiles, Janice, I post yesterday, I spoke about this site a little bit already, so I'm not going to repeat all of that, but just to generally summarize, there's no large PSRs, unfortunately, that are accessible in this region, but there are numerous smaller PSRs shown in red in this map here, or sorry, orange. No, it's orange in this map here. And you can see that they are more frequent at the lower elevations around the crater, its ejecta, and then less so on that prominent higher elevation ridge. And many of those lower elevation ones are located within accessible areas with relatively low slopes. Of course, another factor is illumination. Um, And this image here shows the WAC illumination time weighted average with it colorized into 10% increments. And so, while it doesn't cover all of this region, Faustini Rim A, you can probably get the hint that it's not one of the more frequently illuminated regions. And so we've all heard how important illumination and topography and timing are for planning site surface activities. And seasonality is also important, as well as topography and like things like sun-facing slopes. Um, so um, this also leads to the connection between illumination and temperature. And just as an example here, I pulled out 4 panels which show the surface temperatures predicted based on illumination. This is data comes from QuickMap sunlit temperature model. And it shows the 4 different phases of lunar cycle from full moon to first quarter in the bottom right corner. And in this color scale, red is cooler temperature and green is warmer. So hopefully that won't confuse you too much. But um, you can see from the image, though, that over one lunar cycle, the illumination in this region varies dramatically between different portions of it. So Faustini's craters slopes are sun-facing at certain times, and so of course they're very warm. But at those same times, the other areas are not really illuminated much, and so they're relatively cool. And then at other times of the lunar cycle, those other areas are more illuminated, but it's still glancing illumination, and so the surface temperatures are still relatively cool. So this is good in the sense that the lower temperatures might favor more micro to small PSRs, and there's a good chance of finding volatiles outside of Faustini crater. As we all know, the time is very important as well for illumination. So this is an example of a that illumination data codified into a stoplight type chart where red is a day where there's little or no illumination. Yellow is a day where there's moderate illumination, and green is a pretty good illumination day for a particular location. And it's divided into the crater area and the ridge area. And so, looking at this, you can see that the green or favorable illumination doesn't occur at the same time for the ridge and the crater. And so, there's that. And there's also, you can see that they're relatively short durations of illumination, in a few cases more than 6 days. So here's my little animation. So this is basically the same thing, just an animation to show you that the lighting does change relatively quickly for the different regions. So inside Faustini, that ridge and the crater area, and that they aren't illuminated usually at the same time. And those are those same 24-hour time steps. There we go. So then looking ahead to 2026, doing the same sort of thing for a 3-week period of the same Earth calendar days. To just as a comparison, it actually shows that depending on your timing, that you could end up with a worse illumination scenario than the random example that I selected. So this is why it's so important to have modeling done at the notional launch timing so that we can better predict what's accessible and what science we can achieve. I know NASA is working on this based on yesterday's discussions. So just to summarize, Faustini Room A has lots of possible cold traps and volatiles, record of lots of impacts, and there's going to probably be some illumination challenges for this site. The ridge is not intrinsically any better than the crater area in terms of um, overall accessibility and science. It has a few small PSRs, but not nearly as much as elsewhere. And suitability for a base camp would depend. You might imagine some scenarios, but honestly, I'm not super optimistic about it because of the limited lighting. Thank you. I think I'm actually a couple seconds over. Sorry about that.